Here in front of me, I have 3 square blocks of chocolate. Now you have 2 options. Either you can select the 2 smaller blocks or just the 1 largest block. If you're trying to get the most amount of chocolate, which would you pick? Before we make this decision, let's see what we can find out about these particular blocks of chocolate. Each of these blocks is a square, so the sides have the same length and the angles are all right angles. And these lines here are straight and perpendicular, so this angle must be 90 degrees. That means the space in between the blocks is a right angle triangle. Does this help us find out whether the area of the 2 smaller blocks is bigger, smaller, or the same size as the largest block? Let's do an experiment. We'll try making a right angle triangle of our own and creating squares from the length of each side. Here I've drawn a right angle triangle, and when I measure the sides, they are 8.3 centimetres, 14.5 centimetres, and 16.7 centimetres. If I use these sides to make squares, then the area of the first square will be 8.3 times 8.3, or about 69 square centimetres. The area of the second square will be 14.5 times 14.5, or about 210 centimetres squared. The area of the third square will be 16.7 times 16.7, which is 279 square centimetres. So for this example, which blocks would I pick? Well, these 2 smaller blocks together have an area of 210 plus 69, which is 279 square centimetres. That's the same as the area of the largest square. So for this example, it wouldn't matter whether I picked the 2 smaller squares or the 1 largest one, since they both have the same area. But does this work for all right-angled triangles? And how can we show this? It turns out that for every right-angled triangle, the square of the length of the longest side is equal to the sum of the squares of the 2 shorter sides. We can write this fact out using symbols. If we label the longest side, the hypotenuse, as C, and the 2 shorter sides as A and B, it doesn't matter which side we label A and which we label B, as long as we remember to label the hypotenuse as C. So if the first side length is A, then the area of the square will be A times A, or A squared. The second square will be B times B, or B squared, and the area of the largest square will be C times C, or C squared. So for any right-angled triangle, C squared is always equal to A squared plus B squared. This is called Pythagoras' theorem. It's named after the ancient Greek mathematician Pythagoras. So back to our chocolate question, if we turn over each of these blocks, we can count the number of pieces that are on each square. The smallest square here is a 3 by 3 square, so it has 9 pieces. This second block is 4 by 4, so it has 16 pieces. And the biggest block is 5 by 5, so it has 25 pieces. Now, if we chose the 2 smaller squares, we would end up with 9 plus 16 pieces, which is 25. That is the same number of pieces as are in the largest block. So whether we chose the 2 smaller squares or the 1 largest square, we would end up with the same amount of chocolate. And that is exactly what Pythagoras' theorem tells us to expect.